So this is a presentation for workshop 2 in the APS 145 Applied Problem Solving Program. And the workshop 2 is about a weather system. So the workshop details are the city winter weather dispatch service department needs a tool that will advise the city service clerks what resources are required to treat a given set of winter weather conditions. So as you can see here, we have an input conditions and we have prescribed output conditions. In the input conditions, we have the precipitation accumulation and the temperature range. The prescribed outputs are number of plows, number of sand trucks, and number of salt trucks. So using the amount of accumulation as regards to also the temperature, certain outputs actions will happen, like one light truck or one normal truck or one heavy or two heavy trucks. So as you can see, there's different weather types that are in this depiction here. Is we have a snow condition type, an ice condition type, and a mixed condition type with all their different values. So in the pseudocode, we have a main process and a sub-process. In the main process, it depicts when the weather tool starts to input the type of weather, snow, ice, or mixed. Another input is the accumulation plus temperature, which will equal the number of plows or sand trucks or salt trucks. And if none of those are applicable, and also that you can input if it's a state of emergency, considering the amount of accumulation and temperature. In logic 1, the snow here, it shows the conditions, the accumulation, the temperature. The accumulation is 2.5 centimeters with temperatures -10, temperatures -10 to -5, temperatures -5, and what those output actions should be, such as one light or null, there no truck needed or no action required. And it keeps going on with different conditions of accumulation and temperature, and what the output actions should be. Even in a state of an emergency, there will be down here in 15, output action uses J, state of emergency, organized army and other jurisdiction support, as you saw in the first first description. There's also another weather type here, ice, which depicts whether there's no action or if there's salt or sand or plow trucks that are needed. And it goes through 4 conditions. The first one goes through 5 conditions. And the third one goes through 5 conditions. And then the system ends. Also, the system will restart if one of the inputs isn't what the input you want. You can restart it and select snow or ice or mixed, and then enter the accumulation and temperature or a state of emergency. So if you don't want snow and you don't want to enter the accumulation temperature or a state of emergency, you can pick ice or mixed as well. In the flow chart here, it shows what we enter the weather, and then we determine what type of weather there is, whether it's snow, ice, or mixed, and then we call processes logic 1, call process 2, process B, logic 2, process C, logic 3, and then the system ends. So you can see that this system would work quite well because it's very sleek and useful for a city to use to determine what output actions they would need concerning their weather conditions, including the weather type, the weather accumulation, and the weather temperature.